So have you installed your Wave software? So some people utilize the software in this computer room. Yeah, I'm sure that you can access. So you can finish your assignment 3. So if you have your own computer, so you can install. So you can easily follow this website. Let me show you the little bit important guideline for. So you can say how software. So you can go to your design software website. So you need to sign up first, and then you can have an instruction here. So you like to download or update your software. So if you, oops, has failed. So when you download this updated version, so 1.85, so you just carefully look at what's the requirement for the system. I don't think the Apple can support this software. The Windows OS has to be utilized. And look at the system requirement, download your software. And then important information is the property. So when you don't do this one, you cannot see the report, final report. So you have to go properties, then general, and then your file is blocked. So ensure the unblock box at the bottom. So if you go to your software, so you can see the detail here. So Wave software, where is Wave? Wave. So you have a Wave here. So you just click the right button. So run as a administrator. Yeah. And you can see also property in this software. And then you need to click you need to operate this one as a administrator. Otherwise, you cannot get your information from the final report. So let me show you. So everybody check carefully for this unlock the box for your administrative role, and then learn as an administrator has to be set up. Otherwise, you cannot see. So you can see from our program, we are handling as a learn as a software from this part. So you have to set up this one first to see all the detailed information. And you can start to design your software. So you can install from your computer and utilize your assignment at home. So while the computer is come through, anytime you can, I know you have ID, so you can utilize your computer software here. So let's go for our wave software. So this is the first screen. You have detailed information. What's the unit do you have to use? And then settings, feed water, setup, and final report we can utilize. Also, you have a tabs. This tab is very important as well. The feed water characteristics, then how you want to design from pre-treatment, and then some of the demineralization, reverse osmosis, ion exchange, or also polishing, like ion exchange compound, also spread of the mix point can be utilized. And this is the feed water side, reverse osmosis membrane design. So you can put how many elements, one membrane type do you want to select, what's the feed flow rate, concentrate flow rate, average, the water flux you can utilize, also how many elements you need to. So everything you need to put into the reverse osmosis, what we have studied last session. And then you put your technology inside. So what's the feed water? What technology do you want to use? So your assignment has the two options. One is the pure media filtration treatment or ultrafiltration. So when you use ultrafiltration, there is a section of ultrafiltration in the software. So you can also design together ultrafiltration RO. We haven't really covered ultrafiltration because filtration is the several options. So we didn't really specify the full design, but you can select based on your own interest or your own design. Ultrafiltration also has a very useful sample file in the system. So there are given sample file. If you just click the file, open the project, so you can select some of them, ultrafiltration, also RO, also breakage water, seawater, and different wastewater. So you can have a selection as well. So you can just put your pre-treatment in front of them, but your media filter is not available in the system. So if you want to use the pure media filtration system as a pre-treatment, you can design by media. So design of pure media filtration is relatively simple. So this one can be available from any of the internet information for filtration or pure media filtration design. So relatively simple pre-treatment you can put in your assignment. Otherwise, you just utilize ultrafiltration as a pre-treatment design together. So there are two options you can select for your assignment. So after you design feed water, reverse osmosis, summary report. So summary report will provide what's the wrong with your design, what's the chemical fouling issue, what's the pH issue, what's the different kind of concentration. Also, you can see the concentration of feed water and permeate concentration and concentration. So all each individual ion can be shown in this software. So you will see the final product so that when you have your assignment 3, the boron concentration should be less than 0.3 milligram per liter. So if your design of water concentration is more than 0.3 milligram per liter. So you need to go back and then select the second part and then make sure your boron concentration is less than 0.3 milligram per liter. That's why you have to do that. So after this basic information, so you can put one by one all the detail. So you can see what's the feed water. So stream 1, stream 2, so you may have a different stream. So you can put stream 1, this quality coming through 80%, stream 2, different water quality or different feed water solution. To stream 2, maybe 20%, 60%, and then you can incorporate this stream 1, 2, and then you can put all the information. So water type is seawater, and the subtype is conventional pretreatment you utilize, or ultrafiltration you use, and what's the turbidity, total suspended solid, SDI. So already we discussed about SDI. SDI should be less than 5. Most of our pretreatment can achieve less than 5 SDI filtering. So you can put the SDI value inside your software, and then organic compound, how much concentration, and you can put ammonia, potassium, sodium, magnesium. So all your given condition are available in your scenario. So if you look at the scenario for your assignment at the end of your document, the appendix provide your water quality of seawater. So you can utilize the given water quality condition and put into your cationic compounds as detailed as possible. Anionic compound you can put into this concentration, and then neutral like silica oxide, boron concentration. In general, boron concentration 5 milligram per liter in seawater. We need to target less than 0.3 milligram per liter, and then CO2 concentration and temperature. The minimum, your temperature, winter time, maximum temperature in the summertime. Then you design the middle of range of temperature in overall, and you can also select and pH. So seawater pH is 8, and we need to decrease the 6. And sometimes you may have a different pH, so you can select your pH of the feed water. So you put all the basic water quality parameter in this software. After that, we will go for all the detailed design of, already we covered this one, as reverse osmosis. So reverse osmosis, you can see pass 1, pass 2. So you can design separately. Pass 1, normally high rejection reverse osmosis membrane you need to select. Pass 2, the BWR is okay because already it's permeate, so it's very clean. So you select the BWR, pass 2, membrane type, and then you have to design pass 1, pass 2 separately. So you just click pass 1, pass 2, then what's the stage you want to use? Pass 2 stage, just 1 is okay. Pass 1 stage should be 2 stages for seawater desalination. So you select your stage, and then based on that, also you can have a flow factor. What's the flow factor? Flow factor means your membrane performance. Like you have a flow 100 coming through your feed water, But the problem is that when you operate new membrane, first 1 month, your performance is 100%. Yeah. But after 1 year later, your membrane is aging and then fouling and damaging. So your performance of the membrane after 1 year potentially reduced 10%. So in this case, you design 5-year membrane lifetime. So you put the always new membrane, which means your ideal condition of your flow. However, real condition is always they are decreasing the performance level. So we just put normally extra 10%. So 0.9. So 90, even though your design is 100 kilometers per day coming, but we produce 90. So 10%, 0.9 flow factor, because after 1 year, your membrane performance will be jeopardized, and then this can be considered as a flow factor. So some of the feed water may be 0.8, 0.7. So depending on your water quality, we give a little bit of extra flow condition and temperature, design temperature, and then plus permeate back pressure. I think that at this stage, you don't have to worry about too much back pressure. And then feed flow rate and recovery rate and the permeate flow and flux. So it's a given flux. And then the permeate split flow. So you can select what's the pressure per stage. Pressure vessel. How many pressure vessel you need to design feed flow rate 75,000 cubic meter per day. Permeate is 32,000 cubic meter per day, 30% of the recovery rate. How many pressure vessel? We need 285 element. How many we put the element in one pressure vessel? And then what kind of membrane? Seawater 30. High rejection membrane we select, and then we select what's the pressure, stage back pressure, and this can be considered. After you collect all the detailed design of the reverse osmosis membrane and analysis, and you're confident how to make a good design parameter. So when you design, so you can see this kind of information. So you have one module pressure vessel, and then how this is flowing, and then second pass, how this will work to make a split or concentrate at different back pressure condition. You could incorporate some of the chemical inside. So after you design this one, so you can select also some of the summary. So this is the information in a first stage, and then pH can be also incorporated with the different chemical. So you can have some more option, add chemical. So pH, you can put the hydrogen sulfate, make a pH 6. Then what's the potential of different deeper adjustment of the pH after pH decreased, and then what's the pH change of the RO pass. So you can see the red color here, 1, 1, 3.1, 2.37. So based on this information, yeah, you can go back. Oh, this is the too high, the LSI value. So what is the LSI? And what's the calcium sulfate potential fouling? So you can see the concentrate of the after pass, the calcium sulfate, calcium fluoride, and then some of the magnesium hydroxide. is a red color is shown in this software. So in this case, you need to also try to change the pH. So add a pH will make you this red color disappear because how this water chemistry works. So let's see the little bit of detailed LSI value. The LSI value is the carbonate scaling potential. So in the software, LSI value is very important because you can see what's founding could be created on the membrane surface. The calcium carbonate, calcium phosphate, calcium sulfate could be the major founding condition. So we look at the software. Software will calculate automatically based on your ion, based on your total dissolved solid, and pH. We calculate as the water chemistry and shows the red sign. Okay, you already show 1, 1, 2, 3 in the different feed flow rate, permeate flow rate, concentrate flow rate. So you can see all the detail. So how they calculate LSI value? LSI value we just call Langelier saturation index scale potential. So negative less than 0, no scaling potential. The water will dissolve as a calcium carbonate. However, positive greater than 0. So previously, you just saw that our LSI value is before adjustment of pH. When pH A, LSI value 1. After pH same, and then RO concentrate 3.3 increased. So how we can make this red color to the black color? So it has to be, we have to have a negative rather than positive because positive means scale can form. Calcium carbonate precipitate may occur. Close to 0, borderline special scale potential, water quality, temperature changes, or evaporation could change the index and input the alkalinity, calcium hardness, total dissolved solid, actual pH. Overall, this condition will impact LSI value. So LSI value is equal to pH. So what's the pH? Minus pHs. So when you have a higher pH, you will have a higher positive LSI value. When you have a low pH, you have a negative or less than 0 LSI value, which means no scaling, no fouling. So LSI value, calcium, pH, carbonate, temperature, total dissolved solid as aggregated information. So we have to see carefully as the fouling potential. So when you concentrate more salt in your desalination process, you have a higher value of the LSI, which means more fouling potential. So LSI pH, let's say we have a 6 as a adjusted pH minus pHs. pHs means, so we have a equation 9.3 plus A plus B plus minus C plus D. The A is the log 10 TDS concentration. So we have a 35,000 milligram per liter of seawater TDS. And minus 1 to 10. D is the temperature. So when you have more temperature, higher temperature, you may have more fouling potential. So you can see what temperature will affect overall log 10, your temperature plus 273 plus 34. So you will calculate what's the B value in terms of temperature. C is the calcium concentration. The calcium is high in seawater concentration. So most of fouling start from calcium carbonate. Calcium carbonate is the most common membrane fouling for seawater desalination. That's why we look at this trigger concentration, which will give overall your design is better, or we will have a lot of fouling potential. The calcium concentration minus 0.4 C is the alkalinity, and the calcium carbonate concentration easily combined together because seawater contains a lot of bicarbonate from the CO2 in the air. They are all dissolved in seawater. So carbonate concentration from CO2 in the air very high in seawater. So we look at this LSI value. So must be less than 0. And then you don't have much fouling potential. So to reduce your fouling potential, decrease the pH more, or you can control your TDS, you can control your temperature, calcium concentration, will give you better design of the membrane fouling. So that's how we calculate for the RSI value. So when you see the red color in your report, you have to go back. You have to change the pH. You have to change the temperature. You need to change also some other different calcium alkaline concentration, which can reduce this kind of inorganic fouling on the membrane surface. So this will happen when you concentrate more and more your seawater, desalinate, and then this will continue to increase. Yeah. So based on this one, we have to also look at the report. So if you click the summary report, the RO summary, you will show this diagram we designed, and then you will get all the detail flow, total DDS, pressure, each portion like 1, 2, 3, 4, 5, 6, 7, and all the position, you will get the detailed information. And then RO system overview. So you can see how many parts we use. Parts 2, 1, 2. What's the water type? Seawater, and then less than SDI 3 and 1. What's the number of elements we have designed? 2,000 elements, 600 elements, active layer, and feed flow rate, parts, feed TDS concentration. This is the 45,000 milligram per liter is a Middle East seawater condition. And then parts 2, this is the 288 after permeate, and pressure you apply is 69 bar. The second part is a very low TDS. So we just apply for very low pressure, almost 10 bar pressure, flow factors, permeate flow, average water flux, and permeate flux, and then past recovery. The first pass 43% for seawater desalination, and then after first pass, second pass is 90%. And this one also shows the specific energy required, 6 kilowatt hour per cubic meter. And this is the 0.7 kilowatt hour per cubic meter temperature pH adjustment. And then you will see overall their RO system recovery, and then net RO system recovery, specific energy consumption from the reverse osmosis. Also, you can see each individual ion. So when you have a membrane, SW30, SW, HLLE membrane in the different section. So you can see what you input, your ion, ammonia, sodium, chloride, all the detail. So after feed, this is your value. you input this one, then adjust pH, how this change. And then after recycle, stage 1F position, stage 1F position, permeate quality. So you can see all the detail. So in your assignment, so you look at the boron. Boron concentration has to be permeate less than 0.3 milligram per liter. But still, it's a 0.5. So you have to go back to find out how we can reduce overall targeted fertility. So that's all the detail you can find out from your report. Like if you put your specific feed water individual ion concentration, so your report will show you which position, how much concentration. So you can see the final product and then decide how you can make a better design. So in fact, I utilized the pH. I didn't change here, right? But in the real condition, you change the pH, adjust pH to 6. And then you can have also different information and permeate quality from your summarized report. And this is the design only. So your assignment has to show your RO design only is none. So I utilize this one. And then this condition, your design only is there. But sometimes you put too much recovery rate, too much feed flow, too much permeate flow, too much concentrate flow. So there are a lot of design on it. Also, they have all the detail, the flow, RO flow, feed flow, recovery, feed pass, feed TDS, concentrate flow, permeate flux, permeate TDS. So you can see all the detail of how they flow it. Then making sure you don't have any design on it. Also, you can see the stage level flow table and different stages. So we have first stage, second stage, the feed flow rate, and your concentrate flow rate, permeate flow rate. So it shows the very well balanced your flow rate from your design. You can get this result. And then solute concentration, pass 2, pass 1. Also, you can see the individual ion. So let's look at the boron. Previously, it was 0.1 at the time, pass 1. So we decide to utilize pass 2. So boron concentration after your second part, this is second part, then concentration reduced 0.1 milligram per liter. So pass 1, concentration was 0.55, which was above our limit of the boron concentration. But when you utilize the second part to remove our boron concentration, finally we achieved the limit less than 0.3 milligram per liter. So you have to also check carefully your target ion, how much final product can be produced from your software. So you don't have to do your own experiment because this software will give you each individual, whatever you put, how they can be removed, how they can reduce, how you can change the pH, how you can make a fouling potential. So you don't need a lot of chemistry related background. You just put as detail as possible and change the condition, and you can have a good design parameters in this software. And this is the warning, solubility warning. So as we discussed, this software will provide overall your water chemistry background. So what's the solubility warning we have? The stiff Davis stability index more than 0. NSI value also more than 0. And the magnesium hydroxide saturation point more than 100%, which means they will crystallize and then make the inorganic skin on the membrane surface. Also, anti-scalant has to be added. Otherwise, you will have a lot of polypotential in the water characteristics in the concentrate side. So you can see the red color. After you design, you just click your summary report. This summary report will show you how you design only, also solubility, polypotential only, and the red color NSI value, we have a 1, 1.5, 0.12. So you need to do something anti-scalant adding condition, or reduce the morphine, or remove the sum of TDS, calcium, carbonate, or temperature. You can do something to make a more black color in the solubility warning of the water chemistry. So this software will give us every point how your water is flowing, what's the individual ion is moving around, the concentration after first part, second part, first stage, second stage. So you can see all the detail from this information. So you can decide, this is the best design I have incorporate. And then you can also utilize your design. So this is let me try to practice one. So this is software. You can open it now. So everybody, can you open your software? So you can try some of the file. You can have an example file. Because yes. So first screen is like that. So you can have your condition. Also, you want to use ultrafiltration, just click this one, drag to the ultrafiltration. So you will have ultrafiltration auto design. And then you can just sum of your policing, ion exchange. If you like, you can utilize also some of the split mixture point. Also, you can also drag and you can put the system here. So for me, it's, I don't want to ultrafiltration at this stage. Just let's focus on reverse osmosis. So this is the seawater. You have a selection, different kinds of water quality, wastewater, or RO permeate. RO permeate can be used as a second pass, and then well water, surface water, wastewater, seawater. So we select seawater. Your feed, how much feed you want to put. Let's say I want to design 72,000 cubic meter per day. Product water, I need to have a 45% recovery rate, almost 29,000 cubic meter per day. And based on this one, you just go to feed the site. So I want to use only one stream, seawater. This is seawater and pretreatment. You can select the ultrafiltration, membrane filtration, or conventional pretreatment, and put the turbidity, TDS, SDI, organic. Also, I put the information for sodium concentration is high, 14,000 milligram per liter. Magnesium, calcium concentration is you can incorporate in this the cationic water characteristics and anionic water characteristics. Also making sure your the neutral concentration boron is around 5.16 milligram per liter in seawater. So we put the information, and you need to make sure adjust your balance. So you have adjust your cation, anion, or ions, adjust total carbon, bicarbonate, and carbonate your concentration, because what you are giving is each element. It's not everything inside your water. So you give a major information, but some of the ion is missing. So your water balance, cation and ionic, doesn't match in your water. So you will see the error in this case. So you have to click this one, or just using this basic chemical, and then they automatically balance your cationic and ionic compound, and then you can start. This is not very critical, but you can just click and then go to the next step. Otherwise, this water has the error message. More question?
So for several elements, the concentration so that should be like the solid secrets.
Yes. Yes. No, it's not. You have to put. But another option you have, put TDS. Like, okay, I don't know each individual line. I just know 35 gram per liter. And put a TDS, automatically they calculate at the osmotic pressure, but it does not show. It does not show. It does not show what's the concentration of sodium. Just they only calculate TDS. So in your report, you cannot see sodium, ammonia, manganese. If you don't put the value there, you cannot see anything. Only you can see TDS 35,000 milligram per liter, permeate 100 milligram per liter. It's only this rough data you will get. So we like that's why I have provided your each individual in scenario. But you just utilize the good faith information. But you don't know any wastewater quality, only you know TDS scale. Just quickly just put the value, and then you can run the software. So just the rough data is possible, but when your assignment, I recommend you put all the detailed information here, also your pH, and then your temperature, which will give you the better result. Then reverse osmosis, we just design pass 1 first, and then pass 2 later. So pass 1, we have a first stage flow factor, then what's the flow rate, recovery rate. So when you put the value, so you can put the this value in your system, and then you will have a little bit more detailed input in your feed flow rate, and then permeate flow rate. Also, you can change the little bit of permeate flow rate in your system, and then making sure your recovery is correct, and then plug. So based on your rough manual calculation, so already you know how many elements, how many pressure vessels, how many you need to incorporate. So you need to put the value, membrane, everything in this system. So you can have, okay, how many membrane we need. So if you just click this one, so you can have a more detailed specific membrane type information. So you can utilize one of the membrane module, and this will give a better result. And total stage, bed pressure. So you can see the diagram of this system. and click the summary. So when you click the summary, if you cannot see the summary report, so you may have a little bit of problem for your learn as an administrator, so property setup is problem. Or when you design something very wrong, you cannot calculate the summary. So there are two errors you may have. One is your design is parent. So even this computer cannot provide summary of it. So it's completely wrong, completely doesn't make sense. So in this case, they cannot provide. Or your property of the run-as administrator setup has to be put there. And then you will get the summary report. And this is summary report already we briefly discussed. So you need to also attach this one in your assignment 3. So there are many detailed information, all the specific, the water fouling potential. So you can easily print out as a report. So you can see export to PDF file. So you can export this PDF file for the final report, and then you can provide to your assignment. But if you're a consultant, it's same as okay, I design your plan. Okay, this is the report. Then okay, this is the one. This cycle, as well as how much energy make power consume, and then how this much cost will be required for your system. So if you provide this one to your customer, even your assignment 3, so they will see more detail and then making sure everything is so detailed report was batch. So we have several important information here, how to add some of the chemical, and then how to make sure that your POC rejection. So we have some information of detail, like the project information, also currency. So they also provide some of the economy analysis. So you provide how much the element cost, how much present person cost, how much your energy cost in your country. So you put the basic information in the software, then they automatically calculate how many elements that will be used, energy consumption, operating cost. So you can have enough economic value of your design the reverse osmosis system. So that's what it is. You can have a more specific, but I don't think you have to utilize this economy at this stage. You don't have to do. This one is a more consulting related effort. So we don't have to go for this economy. Just to design RO carefully. Then when you adjust pH, also you can click this one and then put some of the necessary adjust pH and the report type. Also you can select the different report type, and this will give you more detailed information. So this is how we design our water determination, wastewater review, and any type of water treatment. So it's not really difficult once you understand just matter of you clean and play a little bit of change and economic, what the quality system design, how you can make that. Also, it shows the energy consumption. So you can play a little bit how to save your overall energy consumption for your design. So that's also relevant to your design skill. So this is all about the our designing of the our system. Also, if you see the project in the file, you can have a different example. So this is my example. Also, you have a ultrafiltration example for surface water, seawater. So you can also utilize this one as an example for ultrafiltration and combine together with the RO. You will have also to combine the design. Also, you have some of the ultrafiltration, RO, IXMB. So you have a reference here, example. There are many examples, and then nanofiltration, seawater desalination, and you can also have some wastewater in this example. So you can just click and open this example, and then see how this guy designed. And you have also a better idea. Other example will give you a little bit more scheme to improve the web software. So this is very useful. You can get all the specific data to design your reverse osmosis process. And then you need to time to think and then span, and then how you can design for your assignment 3, seawater desalination, 250 million liter per day design of your seawater desalination. So you just utilize the software. So when you design 250 million liter, don't design 200 million liter all together. So make it smaller, like 10 million. So in this case, you can just design only 10 million liter or 1 million liter, multiply by X is 250 million liter. So just to say, okay, I design this 1 billion liter per day, and then make the 250 unit in this system, and you can have different frame applied for your seawater design. So that's how you can try in your home. And then if you have any question, please send the email. Also, we have a consultation timing in 3 weeks. In 3 weeks, your deadline of the assignment 3 is 1st of June. So you have 4 weeks to finalize this assignment. So after 3 weeks and 2 weeks, we will have a consultation timing. So you can come to consultation and then discuss about any issue or any problem, or we can have a discussion together and send the email so we can discuss at the individual meeting to follow up for your design issue. So that's the overall our computer software design. And any questions so far? Do you have any question? No question? It's very easy, right? Just put like a computer game. Yeah. Your computer game. Put yeah. Listen clear and yeah. Put the summary report. And then drag the reverse of your source. And little bit push the value, and you can have a good data from the software. So it's fun. So you can have a little bit of familiarity of this software, which will give you the good design